Alright, next we're going to talk about a process called change of variables. And with a formal change of variables, you completely rewrite the integral in terms of u and du. So it's related to what we've been doing, except now we're going to actually change our variables. So using substitution, if u equals g of x, then du equals g prime of x. So we're just going to be changing g of x into u and g prime of x into du. So if we have the same situation here, that's our pattern recognition, so it's a function of an inside function times the derivative of that inside function, we can rewrite it like this. So it's f of u du. And we know if we have this, we can just take the integral of f at u and then plus c. So we're just making this a little more formal than what we were doing before. So what we want to do here is we want to choose a substitution, u equals gx, and this is most likely going to be the inner part of a composite function. And then we want to find du, which is the same thing as g prime of x dx. Now we want to rewrite the entire integral in terms of u and du. So it means getting rid of all of the gx's, g prime x, and the dx. Then we want to actually find the integral in terms of u, and then substitute g of x back in for u, yielding your function in terms of x only. And then again, you can always check your answer by differentiating. So let's give this a try here. So we have the integral of the square root of 2x minus 1 dx. So hopefully you see this as a composite function. And what we're going to do is let the inside here represent u. So here u is going to be 2x minus 1, and du will be its derivative, which would just be 2 dx. Now, if we want to write this entire thing in terms of u's and du's, well, I know 2x minus 1 equals u, so that's an easy one. But what does dx equal? So what we're actually having to do is solve for that dx right there. Okay? So right here, you might want to add in a little note to solve for dx. Okay, we can do that here by dividing by 2. So dx equals du over 2. So let's go ahead and rewrite this now. We would have the square root of u, and then we would have, instead of dx, we would write du over 2. Just like so. Now, let's clean this up just a little bit. Instead of square root, we would want to write this u to the 1/2. And this right here is a constant multiple, so we're just going to factor that out here. And so we get 1/2 times the integral from u to the 1/2 power du. Okay, so the only little trick that we did here was when you rewrite dx as something times du, it's best if we just take that right outside of the integral so that we can actually take it, because now it's in the form f of u du. Okay, so in our answer here we have our 1/2, and then the integral of u to the 1/2 will be u to the 3/2 over 3/2. Okay, and this will be plus c. Okay, so this will be 1/2 times, well, the reciprocal here, so 2/3 u to the 3/2 plus c. And you can see the 2's will cancel here, and so we really get u to the 3/2 over 3 plus c. And then the last step is go ahead and just substitute u in to your final integral. So remember, u is right here, 2x minus 1, so we're just going to substitute that back in. So final answer, 2x minus 1 to the 3/2 over 3 plus c. Okay, so one thing that this allows us to do is, instead of having to multiply on the inside and the outside, if we can just rewrite everything in terms of u and du, then we're done. There's no more thinking. It's just basic integrating, and then all we have to do is at the end change everything back. Okay, so we're just trying to rewrite this as a simpler form. Let's try one more together. So here I can see my inside function. It's going to be 2x minus 1. So we'll just say u equals 2x minus 1. And now du is going to be 2 dx. Okay, and notice what we need to do now is we need to figure out what dx is in terms of u. So we're just going to divide by 2 here. So dx really equals du over 2. In this one, notice it's just a little bit different because we have an x here. So if we want to rewrite the integral in terms of u and du, we may also have to solve for x in terms of u so that we can rewrite it here. So that's what we're going to do right here. So x is going to equal, well, add 1 and divide by 2. So it's going to be u plus 1 over 2. Okay, so two important things that we just have to do when you make your u and your du is you're going to have to solve for x and dx to substitute back into this equation. Okay, so let's go ahead and substitute everything here. So instead of x, we're going to write u plus 1 over 2. And then this is going to be u to the 1/2. And then instead of dx, I write du over 2. Okay, so now we've rewritten our integral in terms of u and du. Okay, let's just block this off. This is kind of our pre-work here. So looking at this, let's go ahead and factor out our constants. So that's a 1/2 here and a 1/2 here. So that's going to become 1/4. And so we'll be left with u plus 1 times u to the 1/2 du. And now we can't use our pattern recognition here because we have a u plus 1 on the outside. So what we're actually going to have to do is multiply this. So it's going to be u to the 1/2 times u, and then u to the 1/2 times 1. So we still have 1/4, the integral. Let's see, u times u to the 1/2 is going to be u to the 3/2. And then 1 times u to the 1/2 is just u to the 1/2. And now we have the sum of two terms here. So we can go ahead and integrate this now. Still have our 1/4 out there. So we'll have u to the 5/2. And instead of dividing by 5/2, let's just multiply by 2/5. And then u to the 3/2. And instead of dividing by 3/2, let's multiply by 2/3. Okay, and let's go ahead and distribute our 1/4 now to both of these terms. So 1/4 times 2/5 is 2/20, or 1/10. So we get 1/10 u to the 5/2. And then 1/4 times 2/3 is going to be 2/12, which is 1/6. So plus 1/6 u to the 3/2. And we have a plus c. And now we can just rewrite our final answer by substituting u back in as 2x minus 1. Okay, so here and here. Okay, so final answer is going to be 1/10 2x minus 1 to the 5/2 plus 1/6 2x minus 1 3/2 plus c. Final answer. Okay. All right, let's go ahead and try this next one together. We have a lot of notation going on here. Sine squared 3x times cosine 3x dx. And so a lot of times, whenever I see a sine squared, I want to rewrite it to avoid any confusion. And so this is really sine of 3x in parentheses squared. Okay, it might make it a little more clear what our inside function is here. And then we still have our cosine 3x dx. So what that's telling me is my inside function, or my u, is sine of 3x. And so now when I find my du, notice I'm going to have to use the chain rule. So derivative of sine is cosine. So it's the cosine of 3x. But then I also have to have the derivative of 3x, which is just 3, and then dx. And what I can notice here is that in my function I have a cosine 3x dx, and I can see cosine 3x dx right here. So all I want to do here is divide this by 3, and so I have du over 3 equals cosine 3x dx. And that's going to allow me to rewrite this in terms of u's and du's only. So this becomes the integral of u squared, and then instead of cosine 3x dx, I can write du over 3. Okay, so now I have a du over 3. I do want to take out that 1/3. Now it'll just be u squared du. And now it's fairly simple to integrate. So have our 1/3. It'll be u cubed over 3 plus c, which is really 1/9 u cubed plus c. And now we'll replace sine 3x back in here. So it's 1/9 sine 3x cubed plus c. And if we rewrite it using the original notation, we'll have sine cubed 3x plus c. Okay, so the biggest trick a lot of times is figuring out how can I rewrite this in terms of only u's and du's. There's not any one set rule. It's just you're going to have to be on the lookout for things that are going to match perfectly that you can solve for in here. Alright, I want you to give the next one a try on your own. One thing to note in this example is that our variable already is in u, so you might want to try some other variable. You could put this in terms of z, so it'll be a z substitution or a v. It really doesn't matter, so pick some other variable to let your inside represent. Alright, go ahead and pause the video. Come on back when you're done to check your work. Alright, welcome back. So hopefully you found your inside function was u to the 4th plus 2, and I just let that equal z. And then when I found dz, it was 4u cubed du. And I saw that there was a u cubed and a du here. So there's my u cubed and du. So all I had to do is get rid of that 4 to the other side, and then I would have my integrand. Okay, so I had dz over 4, and I was going to replace that with u cubed du. So I have the integral of z to the 1/2, dz over 4, pull out the 4 in terms of 1/4, then integrate this, okay, do a little simplifying here, and finally substitute back in u cubed plus 2 in for z, and there is your final answer.